Good morning. In this section, I will explain what is an ellipse. What is the algebraic expression of ellipse? So here I will write a definition of an ellipse. First of all, I read and explain it. An ellipse is the set of points, sum of whose distance from two fixed points is a given positive constant. So we can draw an ellipse. I write two fixed points. Okay, distance between the point from the fixed point. So I write fixed points are F1 and F2. So I took here P, and you take the distance between P and F1 is PF1, and distance between P and F2 I wrote PF2. These two sum is constant. So you can take another point here, that is Q. So QF1 plus QF2. QF1 plus QF2. That is also a same constant. Let me take this constant is 2A. So these two, sum of these two distances also 2A. So you can take here, that is SF1 plus SF2. That also same as same constant. So such collection of point is called ellipse. Ellipse is a set of all points, sum of whose distance from a fixed point is constant or same. Such points is called ellipse. Okay. Next we can see what are the important terms in the ellipse. So I wrote two focus. First of all, I wrote two focus, F1 and F2. First, I said F1 and F2 are two fixed points. These fixed points are called focus. Focus is fixed point. Okay. Then you can draw a line segment passing these two focus. That line segment is called major axis. So this line is major axis. This major axis intersect with ellipse these two points. These two points is called vertices. A, comma A dash are two vertices of the ellipse. And midpoint of A and A dash is C. That midpoint is called midpoint of A and A dash is center. C is center. Next you can draw a line passing through C and perpendicular to A dash. This line segment is called minor axis. This minor axis is intersect with ellipse B and B dash. These 2 points is called co-vertices. Okay. So these are the important terms of the ellipse. Next, I will explain one of the alternative definition of an ellipse. First of all, I will explain focus, center, major axis, minor axis, and vertices and co-vertices. So we have an ellipse. I took two fixed points passing through a line segment that is called a major axis. These intersection points is called vertices, and center point is called, midpoint is called center, and passing through a line segment perpendicular to the major axis and passing through the center is called the minor axis. Okay. Next, alternative definition of an ellipse is the ellipse can also be defined as locus of points in a plane whose distance from a fixed point and distance from a fixed line. So what is a fixed line? That two distances are same ratio. Such shape of points is called ellipse. So I will explain. Major axis, perpendicular line segment is minor axis. Fixed point F1 and F2. Here A and A dash, B and B dash. You take a fixed line here and fixed line here. These are the fixed line. This fixed line is also called directrix. Okay. So you take a point from an ellipse. Here you take Z, here N dash and Z dash. A is a point in the ellipse. Distance between the point of ellipse and fixed point, fixed line. So AZ. This is the distance between the ellipse and fixed line. And you take this point distance between the focus. Distance between that point and focus. This is a ratio. This is a constant ratio. This is always a constant ratio. You can take another point P. So that is the distance between the line segment and fixed line and distance between the focus. So you can take here M. So PM and PF1. This is a ratio. This ratio and this are same. Some constant ratio. So such type of points are. These two distance ratio is same for every point. Such collection of point is called ellipse. Okay. So you can take distance A to fixed point S or F1, sorry, F1 and A to Z. This ratio is called eccentricity. So you take a fixed point to a point in ellipse and fixed line distance from a point in ellipse. That is called eccentricity. Eccentricity. This is the alternative definition of an ellipse. The set of all points, the ratio of the distance between the points from the fixed line and the fixed point. That ratio is same, then we can say such type of points is called ellipse. And ratio of a point and ratio of a fixed point and ratio of a fixed line ratio is called eccentricity. Okay. Next, I will explain what is the algebraic expression of an ellipse. So this is the major axis. This is the minor axis. Here I took S. Here I took X dash, A dash, A. So this is the ellipse. This is major axis. This is minor axis. This is major axis. This is two fixed lines. Directrix. Okay. Minor axis. Major axis. Directrix. Here two fixed points. S and S dash. A dash. Z dash. N dash. A. Z. N. Okay. Center point is C. And here B and B dash. Okay. So A dash is a line segment of major axis, that is take to A. CB midpoint of A dash, that is called the center. So AC equal to CA dash equal to A. Okay. By the definition of ellipse, AS by AZ equal to E. Distance between a point in ellipse, I took a B a point in the ellipse and fixed a point S. So this distance and AZ, this distance ratio is A. So I can write AS equal to EAZ. Okay. So next AS. What is AS? AS is a distance between fixed point and A. AS can be written as AC minus SC. AC is this full line segment minus this segment is AS. AC is A. We know AC is A. A minus SC. AS equal to A minus SC. So AS is same as EAZ. So we can write this equal to EAZ. EAZ. What is AZ? AZ is same as ZC minus A. One minute. AZ can be written as here E. AZ is this distance. So this full distance minus this AC. That means ZC minus AC. ZC. So that is equal to E. What is ZC? ZC is ZC minus what is AC? AC is A. So E into ZC minus A. That is equal to AS. Okay. Next we can find A dash S. So what is A dash S? A dash S is this distance. A dash S is this distance. A dash C plus CS. A dash C plus CS. Dash C plus CS. A dash C is A plus CS. Okay. A plus CS. A dash, yes. A dash S is a point, a distance between a point of a fixed point of the ellipse and fixed point. A dash is an ellipse, point of an ellipse. S is a fixed point. So A dash S is a distance between a point in the ellipse and a fixed point. That is same as E into a point A dash to the directrix. So we can write A dash set. E A dash set. So here we can write that is same as E A dash set. Okay. So what is A dash set? A dash set is A dash A dash set is set C. A dash set is A dash here, set is here. So set C plus set C plus C A dash. So we can write set C plus set C plus C A dash. What is C A dash? A. So set C. So A dash is equal to set C plus E into set C. A dash set is set C plus A and E is already there. So E into set C plus A. So we got two equations. One is A dash is equal to E set C plus A. Another one is AS. AS equal to E set C minus A. You can add these two equations. S plus A dash S equal to E set C minus EA plus E set C plus EA. So, what is AS and A dashes? Sum of AS and A dashes. What is AS? AS is this distance. AS is this distance. And A dash is this distance. So, we can write A dash. What is A dash? 2A. So, 2A equal to A dash. AS plus A dash is A dash. That is equal to 2A. That is equal to E set C plus E set C. These two cancel. So 2E set C. So 2A equal to 2E set C. So 2 cancelled. A equal to E set C. So set C equal to A by E. So we got set C equal to A by E. Okay. Set C equal to A by E. Next we need to find SC. What is SC? SC can be written as EAZ. SC EAZ. I will draw here. We have an ellipse, minor axis, major axis, and directrix. Here also a directrix. Here Z N. Here A. This point is S. This point is S dash. A dash. Z dash. N dash. B. B dash. So what is here C? What is SC? SC is same as we already write down. I will write AS equal to AC minus SC. AS can be written as E into AZ. So AC minus SC equal to, so what is SC? What is SC? E EA set. Okay, EA set. AC is A minus SC equal to EA set. A set can be written as E set C minus AC. So what is set C? E set C minus A. What is set C? I got A by E minus A. So I got A minus AE. So A minus SC equal to A minus AE. So A minus SC minus A equal to AE. This implies AE minus AE equal to SC. So distance from S to C is AE. So this C is origin. So S will become, this distance will AE itself. So this is the left of the origin. So we can say minus AE and y coordinate is 0. Okay. So I got one of the distance, one of the point, one of the coordinate of the focus. And what is set A? What is set? Okay. What is C set? C set we got A by E. So I can draw the figure once more. Okay. Here directrix. Here directrix. And I have one focus. Here other focus. Here B, B dash, A dash, C, Z, Z dash, N dash, N. So we got SC equal to AE. Distance between the C to S is AE. And C set C. C set or set C equal to A by E. So here C is an origin. So this point is minus AE0. And this line, this point is minus A by E0. And this line directrix is left directrix can be written as x equal to minus A by E. Okay. This equation of this directrix is x equal to minus A by E. So we know the definition of an ellipse. Distance between a point, here P, I took P. So this distance between point to the fixed line and point to the fixed point, these two difference is a same ratio. So I took this P is x, y. So we can take the difference between PS. We know the coordinate of S. So let me take P is xy. So what is the distance PS? PS square can be written as x minus AE square plus y minus 0 square. And what is the perpendicular distance from that point to the directrix. That distance is x minus AE square. So x plus AE square. This is the perpendicular distance from P to fixed line. So we know this distance PS square and this perpendicular distance of fixed line is E. So we can write PS square equal to, this square is E square. So this distance is E. So this square is, here also we got a square. So E square. So E square into x plus A by E square. What is PS square? X plus AE square plus Y square. That is equal to E square x plus A by E square. We can solve here. X square plus 2x AE plus AE square plus Y square equal to E square into x square plus A by E square plus 2x A by E. So you can solve otherwise we can solve one of the other method. Here x square. Here also x square E square. So these I took same side. So x square minus x square E square. Okay. Here plus Y square. So you can write plus Y square. What is the balance term? Here you know. Here you know 2AES. 2AEX minus plus 2A by EX E square. So here you can take minus left to right. So this minus. So minus 2AEX plus 2AEX EE cancelled 2AEX plus A by E square into E square plus AE square. So A by E square plus AE square. So these two are cancelled. You got A square plus A square E square. So here minus. So you got A square E square. So here you got x square, you can take outside 1 minus E square plus Y square, that is equal to here minus. A square you can outside 1 minus E square. So you can divide this equation by A square 1 minus E square. So you got x square by A square plus Y square by A square 1 minus E square equal to 1. So you can take b square equal to a square into 1 minus e square. So you can write x square by a square plus y square by b square equal to 1. So this is the standard form of an ellipse. Standard algebraic equation of an ellipse. Okay. So you know b square equal to a square 1 minus e square. So you can write b square equal to a square minus a square e square. So b square minus a square equal to minus a square e square. So a square e square equal to a square minus b square. So therefore e square can be written as a square by minus b square by a square. That can be 1 minus b square by a square. So eccentricity square in the ellipse is 1 minus b square by a square. So this is always, eccentricity is always less than 1. Therefore, eccentricity is always less than 1 in the case of an ellipse. Okay? An ellipse is an symmetric of a major axis and minor axis. So you have an here a focus. So you have another focus in this side also. So you got A E 0. Here you got minus A E 0. So A E 0 is also a focus. And here you have a directrix x equal to minus A by E. So by symmetry, so here also